Hello, guys. All right. So I wanted to make this video a long time ago, but right now, since I'm already back to winding, I want to put it up because it's about the coils and their projection of the magnetic field on space. And I want to establish a difference, a radical difference that there is between a coil like that, which is the spool that I use just to count the length of wire that I have, is 23 gauge, 307 feet. And it is about the same, internal diameter. It's about the same, except that this winding right here is a random wire. I do it as I pick up the wire and just wind it in here. It's not compact, it's loose. It doesn't follow a pattern like this one does. These ones have exactly, all of them has 13 layers, and each layer has 24 turns. So this one, I cannot tell you because it's just randomly wound. Now, the resistance, I'm measuring it on the Hioki meter, is 6.36 ohms. And I'll measure the resistance now on this coil here. And that will give you 6.46 ohms, which is not a big deal. It's 0.1 difference, but it's around the 6 ohms difference. However, when we come into inductance measurement, this is my inductance meter right here. I have it set up at microhenries, 200 microhenries, and I'm gonna measure the inductance on the big spool of wire. Okay, and we have 6.5 microhenries. Okay, now when I go here to this excuse me, catch kind of a cold. We can see here the difference. It's more than double the amount of inductance, 13.5. And as we know, inductance it's the opposition to the change of magnetic currents on the coil. But at the same token, if we apply that into the magnetic field, it's the tendency to retain the energy stored on the magnetic field also. So a higher inductance coil, it retains more time the magnetic field within, and that's what we're looking for. Of course, now I am going to do a quick readout of just one coil that is mounted here, number one coil, which I'm going to hook it to the inductance meter and to give me the inductance on that coil. Okay, so now we have double what we have with an air core, because it's got a steel core already mounted on a steel core, and it's part of it. Now, it will not change by me moving it because it'll be moving around the same steel core. Now, the difference is obvious, and it's very different. Now, that's the reason why I spend so much time explaining how to build one of these. That doesn't have a spool. It's not mounted on a spool. It's not randomly wound. It's very compact, very precise. There is no air pockets, loose wires, and every loop is winding on the same direction. So it's a projection on space of the magnetic field spectrum. It's different here than here. They are not going to project the same. And for that, I have set up the PSU at 6 volts, and I'm going to power it up to demonstrate the differences on this. I'm going to add 6 volts to the spool of wire here, and we're getting 0.9 amps. I'm going to bring the meter here, and I'm going to show you what it does here. So we're only going to measure on the center of the spool. We got, I'm sorry, I'm going to turn it to Gauss, and we got 11.9 Gauss. We can say 12 Gauss. Yeah. Excuse me. Now I'm going to do the same thing on the other coil. The one that we have, the one that I just finished winding. And I'm going to measure, powering it up. It's about the same, 0.8. And I'm going to measure here on the center, and you see that amount, 32.8. That's more than double the field strength that is projecting out. And guys, this is very important that you do the coils as I recommend. If you do it like this, random, you won't have the same results when you finish your work. You'll be wasting time. You may have good results. I'm not saying you're not, but you're wasting a lot of field on the outer space here that you don't need to. You need to concentrate the field within the core, not to go out. And if we have loops, turns of wire that are going in an angle, they're projecting field indifferent. It's like a projector, like a film projector. If you have the lens scattered and they are shattered or cracked and has air bubbles, every time light goes there, it'll diffract and it'll go into different spaces. And at the end on the screen, you won't have a clear, neat, condensed view of the projection. So the same thing happens here. I haven't spent that much time explaining how to make these coils, the sequential coils. Now the secondary, they don't matter, but it does. At the same token, they also should have the same pattern. But most importantly, the inductor coils, the ones that are generating the field which is going to induce on the rest of the system. All right, guys, so I think I have covered up everything, and thanks for watching.